Alright guys, that was a totally random video. Awesome fight scene. I love Darth Maul. Can't beat it. Okay? So you gotta imagine like Darth Maul is the keystone and you guys are like the Jedi Knights getting ready to take it out. So that was my analogy for the day. Alright, today we're gonna take a look at use data to problem solve or make predictions. So let's get going. Number 1, use the values below. Summarize the high temperatures in West Lawn, PA for the month of July. Use the values to construct a box and whisker plot. Alright, so when you construct a box and whisker plot, the min is one of your whiskers, so that's 79. Okay? The start of your box is Q1, so that's 86. The middle of the box is your Q2. You come over here to 92.5, okay? And then the end of my whisker is 97. Normally, you would have, you would put a number line down here and you show that as you go. On the keystone, they would probably give you the number line, so don't stress too much about that. But there you go, okay? What is the interquartile range of the data set? Guys, this is super easy. It is just Q3 minus Q1. So I am doing 92.5 minus 86. Okay, just using my numbers over here, which gives me 6.5. Okay, cool. What percent of the days were above 86 degrees? So here's 86 degrees. Each of these spots is 25%. So 25, 25, 25, 25. So above 86, you got 25%. Another 25% adds up to 50. Another 25% adds up to 75%. Okay. What percent of the days were between 88 and 97? Here's 88. Here's 97. There's 2 spots. That's 50%. What is the range of the temperatures? Now, regular range, you take your high, your max, minus your min. Max minus min. So we're looking at 97 minus 79, which gives us 18. Okay? Wonderful. Okay. Pardon me for a second. Sorry. Okay. The band director surveyed students about their favorite musical instruments. The results are shown below. It is estimated that 170 students chose the piano as their favorite musical instrument. Based on these results, about how many students did the director survey? Okay, so the piano is 30%. You want to know how many total students there are. I don't know what that is, so I'm going to call that X, total students. Okay. Now, 30% of them, so I represent that as decimal as 0.30. If you multiply 30% times your total students, you should get 170. Cool. Well, I want to solve for X. So I've got my graphing calculator here. Okay. I'm dividing both sides by 0.3. So 170 divided by 0.30. 566.66. You can't really have 0.66 of a person, so we'll just round down. 566 students. Okay, cool. Number 3, based on the graph to the right, what would be the cost of using the phone for 10 hours? Now, if you can see, it only goes up to 6 hours. Oh no, what am I going to do? Well, try and find something that's nice. So, for example, after 2 hours, it costs $10. Okay, 2 hours cost $10. Well, if you want to find out for 10 hours, okay, I got to multiply 2 by 5. So that means 10 hours cost, I multiply the $10 by 5, $50. Okay, so you're extending it as you go. Now you could extend this graph over here as well, but this is probably an easier alternative. Okay, wonderful. On the back, we're almost finished here. Number 4, the graph below shows the number of gallons of water sold each month over an 8-month period. Based on the trend shown on the graph, what is a reasonable estimate of the number of gallons of water that will be sold in the 12th month? Okay, so we're looking for trends. Every month, my gallons of water is going up by 25. So every month, gallons going up by 25. So let's do the easier way here. At the 8th month, I have 375 gallons. How did I do that? I went here. I went straight across the 375. So the 9th month would be 400. Okay, so 9th, 400 gallons. The 10th, 425. The 11th, I think you guys get, I don't keep doing it plus 25, but good for you to see it. 450. And the 12th month would be 475 gallons. Right? Again, make it simple on yourself. Wonderful. Okay, the population of Landville has been increasing since 1980 as shown in the scatter plot below. Draw a line of best fit in a coordinate plane for the points shown for the Landville population scatter plot. Okay, so line of best fit, you guys would like to take out a ruler, okay, something of that nature, and I want to try and get as many points as I possibly can, or try to get it through the middle of everything, okay? So, I'm going to go with this. Okay. Not bad. All right. Your line of best fit might be a little bit off, like yours might be a little bit higher. It's all good, okay? Write an equation of the line you drew in part A. Now, I need two things. I need an M and I need a B, okay? So the B is pretty easy. Where is my line hitting the y-axis? B is where it hits the y-axis, okay? This is the word hits, by the way, I'm sure. My handwriting's terrible. So that is at roughly, my line's hitting at 1200. So my plus B down here is plus 1200. Now I want to find slope. Let's check this out. Here's one point, all right? And here's another point where it roughly hits. So my rise, I'm going from 1200 to 400. So my rise is 200. From here to here, it's 2. My run is 2. So rise over run, 200 over 2 is 100. So my M is 100. Okay? You want to take points off of the graph you drew, not the random points that are on the scatter plot. Using the equation you wrote in part B, predict the number of population in Landville in 2010. Please show your work. Now, since 1980, this will trip you up a little bit, okay? So since 1980, how many years is 2010? Well, 2010 minus 1980 gives you 30 years. Okay? So I'm going to plug 30, plug in for x. So y equals 100 times 30 plus 1200. Okay, a little bit of calculator work. Okay, 100 times 30 plus 1200, 4,200 is the population. Okay, so that's all for today. You can start to work on your classwork. Keep in mind that may the force be with you. And as always, good luck. We're all counting on you.